Yes, hello everyone, and I am Jula Mzungu, and today I'm going to teach you about the preparation of standard solution in the laboratory. So this class is very important for the chemists, laboratory technicians, and us teachers who are teaching chemistry at school because it can help you know how to make the standard solution in the laboratory. So what is standard solution first? It's just a solution which is accurately known in its concentrations and can be prepared in the laboratory using two methods, that is dissolving and dilution. Dissolving means you have a solid chemical, then you're going to dissolve in a solvent to make a solutions, while the dilution, we have already pre-existing solutions, then we add more solvent and we lower the concentration by adding more solvent making a solutions. That's two methods. So today I'm going to show you these two methods, how they can make a solution in the laboratory. Let's start now with a solid form into a solution, that is dissolving. And we start directly with task number 1. Prepare 0.1 moles of sodium hydroxide, about 1 liter. So when they give you a task like this, it's very simple. First, you ask yourself in your brain, what solution are you going to make? Then that will get you to know what chemical are you going to use. So this sodium hydroxide, here it is. I have my sodium hydroxide pellets. And then what molarity and volume do they require in making those requirements? And it is 0.1 given there, moles per centimeter cube, and 1 liter. So after getting those, just use the relationship which say mass is equal to molarity times molar mass times volume required. And molarity has been given there, it is 0.1 moles per centimeter cube, while molar mass, you can read in the container directly here, it is 40 grams per moles. This is the sodium hydroxide, and the volume required, it is 1 liter. So when we times here, we're getting 4 grams. So this is directly and okay if your chemical it is 100% pure. But mine here, it said it is 97% pure, so it's not 100% pure. This means in these 4 grams of sodium hydroxide, there is other material inside. There is sodium hydroxide and the other material mixed in. So it is not pure sodium hydroxide. So when you measure this 4 grams, it will be less than 4 grams. What you should do now is find the actual weight by using the formula which say actual weight is equal to impure weight divided by percentage purity times 100. And here we're getting 4.12 grams. So instead of measure 4 grams for this sodium hydroxide, which having 97% pure, just measure 4.12 grams to get exactly 0.1 moles of sodium hydroxide, about 1 liter. The task number 2 say prepare 2 grams in 500 mils of sodium hydroxide, about 1 liter again. So now this task has been given us concentration and not molarity, and we need to find molarity first to know what are we going to make. But we can use the formula which say molarity is equal to mass given divided by volume given but in decimeter cube times molar mass. And when we insert our data here, we can get 0.1 moles per decimeter cube. This is the required molarity. Now we go back in a normal relationship which say mass is equal to molarity times molar mass times volume required. Molarity calculated here, it is 0.1 moles per decimeter cube, while molar mass, it is 40 grams per moles, read here directly from the container. And also, the volume required, it is 1 liter. So when we times here, we're getting 4 grams. Again, because this is impure, having 97% pure, it's not 100% pure, so we cannot use directly this 4 grams. It will be less than 4 grams. We should find the actual weight using the formula which says actual weight is equal to impure weight divided by percentage purity times 100, yeah, and we are getting 4.12 grams. For this sodium hydroxide, instead of using 4 grams, for this specification, we need to use 4.12 grams to get exactly 0.1 moles of sodium hydroxide solutions, about 1 liter. This is all about the solid form into a solutions. So let's now see the second method, that is dilution. I mean solution into a solution. Dilution means to weaken the concentrations. So we add more solvent into a solutions which is non-concentrations, then we tend to decrease its concentration while increasing the volume. And here we're going to use the dilution law which says C1 V1 is equal to C2 V2. Well, C1 it is initial concentrations and V1 is initial volume. C2 it is final concentrations or required concentrations, while the V2 is final volume or required volume. This method of making cell solutions can be used most in making solution from the mineral acids and bases. And point to note here is most of the acid bases, they are not indicate their molarity or molar concentration on the container, but they give us information that we can use to get the molarity or molar concentration. And those information is like percentage purity, density, and molar mass. And we're going to use the formula which say molar concentration is equal to percentage purity times density times 1000 divided by molar mass times 100. Let's go right in the task again. Task number 3, which say prepare 0.1 moles of HCl, hydrochloric acid, about 1 liter from the stock solutions. As I said, because this container doesn't have the molar concentration, but they have information that we can use to get the molar concentration. So those information, it's like percentage purity, density, and the molar mass. Okay, we're going to use the formula which say molar concentration is equal to percentage purity times density times 1000 divided by molar mass times 100. So our percentage purity here, it is 35. Density, it is 1.18 gram per centimeter cube times 1000 divided by molar mass, it is 34.46 meaning gram per moles times 100. So when we do calculation here, you can get 11.33. This is a molar concentration of the stock solutions. Now we're going to use the dilution law to find the volume we should grab from these stock solutions to get exactly the requirements. By using dilution law, which says C1 V1 is equal to C2 V2. Well, C1 it is 11.33, V1 we don't have, it's unknown, we are looking for. And C2 it is 0.1 moles, while the V2 it is 1000 milliliters. So whenever times we divide both sides by this as C1, meaning concentration initial, we are getting 8.83 milliliters. So this is amount of HCl we should grab from this stock solution to get exactly 0.1 moles of HCl, about 1 liter from the stock solutions. The task number 3 say prepare 0.1 moles of hydrogen peroxide, about 1 liter from 100 volume. So here is the hydrogen peroxide. It's okay, most of peroxide they give us concentration in the strength, sometimes volume strength or the weight strength. So here they say prepare from 100 volume. What they say 100 volume means, there is what they mean. This means 1 liter of peroxide is equal to 100 liters of oxygen by volume. So when we decompose peroxide, we can get water plus oxygen. And this can show that 2 moles of hydrogen peroxide leave us 1 mole of oxygen. But we know that at TSTP, 1 mole of oxygen having 22.4 liters by volume. So now we need to know this 100 liters will having how many moles of this peroxide. We cross multiplication here and we're getting 8.93 moles. So this container which is returning 100 volume, it's having the molarity of 8.93 moles by calculation. You put in your mind that. After getting the molar concentration, in the C1, we are going to use the dilution law to know what amount we should grab from this stock solution to prepare the 1 moles of this solution, about 1 liter. By using the dilution law which says C1 V1 is equal to C2 V2, while C1 it is 8.93 moles, and V1 we don't have, we are looking for, then C2 it is 0.1 moles, and the V2 it is 1000 milliliters. We divide both sides by the C1 and we're getting the V1 it is 11.20 milliliters. So this is amount of the stock solution should grab from our stock bottle here to prepare 0.1 moles of 1 liter of hydrogen peroxide from 100 volume. Sometimes they can say 100 volume or 30 volume or 50 volume or 10 volume, it depends. Okay, the task number 5 say prepare 0.1 moles of hydrogen peroxide again, about 1 liter from 30% weight by volume. So now they can see they've been given us in weight strength. So when they say 30% means there is 30 grams in 100 ml of a solution. So we need to know now in 1000 milliliters to be how many grams. So we cross multiplication here and we're getting 300 grams. So this means there are 300 grams in 1000 milliliters or 300 grams per liter. So this is the concentration for our stock solutions. Now we need to know how can we get the molarity. We can use the formula which say concentration is equal to molarity times molar mass. So our concentration is 300 grams per liter time, is equal to molarity we don't have, then times molar mass, that is 34.01. So we divide both sides by molar mass and you can get the molarity. It is 8.820 moles. So after getting this mole concentration, you're going to use the dilution law to get what amount you should take from this solution to prepare almost this 0.1 mole, about 1 liter. C1, V1 is equal to C2, V2. So C1 it is 8.82 moles, while the V1 we don't have, so we are finding is equal to C2 is 0.1 moles and the V2 it is 1000 milliliters. We divide both sides by the C1 and we are getting the V1 it is 11.33 milliliters. This is amount of solution, our stock solution should grab from this container to get exactly 0.1 moles of hydrogen peroxide, about 1 liter, from 30% weight by volume. That's all about making these two solutions by dissolving and dilution. But point to note here is, when you make this solution, it says never do wa, but do our. Never do wa means never add water to acid, but add acid to water. When you add water to acid, large amount of heat will liberate it, and then it can vaporize acidic water. Also, it can splash on your face. So take care when making these solutions. Thank you very much for watching, and my name is Jula Mzungu, and don't forget to subscribe and like in my channel. Bye bye.